All right. A while ago, we looked at section number 13. Okay. And we are going to be looking at section 14 today. Now, under section number 13, we basically use the formula sheet, your yellow sheet, which is pages 2, 3, 5. Is that okay? And we are basically going to use the same pages 2, 3, 5. Now, before we start this conversation, let me say that I'm going to break section number 14 into 3 separate videos. So the first part of the video will be from pages 171 to 174, where we talk about areas and volumes, or square units and cubic units. And then the second part, we are going to look at pages 175, where we discuss dosage calculations. And then the third video will cover CO2 or carbon dioxide emissions. Okay, so let's get the conversation going. Now, so dimensional analysis is more all-encompassing term for any kind of quantitative conversions. Is that okay? Now, we looked at 2 different ways to do this approach in section 13, where we looked at the factor label method. And we also looked at using the proportion approach. Here, we are just going to scale this up and talk about 2-dimensional and 3-dimensional. Okay, nice. Now, you remember this formula, this table? So this is the table on the formula sheet on pages 2, 3, 5, the first table. So when we dealt with section 13, we were looking at 1-dimensional space or 1-dimensional units. Now here we're going to deal with 2-dimensional. And by 2-dimensional, I mean, if I do x times x, this should give me s squared. And this is 2-dimensional. Is that okay? If I do x times x times x, this will give me what? S cubed. And we call this is 3-dimensional. And that is 2D, I would call it just simple 2D. Is that okay? So basically we are going to scale up these units into 2-dimensional and 3-dimensional, okay? So for instance, 1/4 is 12 inches. Now in square unit, what we mean is that we are going to square this. So that means 1 square foot is 12 square inches. And this means that we are going to do 1 ft squared is, now 12 squared will give you 144. And then you do inch squared. So 1 square foot is 144 square inches. Is that okay? So this is 2-dimensional, 2D. If you wanted to do 3D, we have to cube that. So 1 foot is 12 inches. If you want to change that into a cubic unit, we will cube that and cube that. So 1 ft cubed will be 12 cubed. Okay, so let me do that. 12 cubed and then inch cubed. Now what is 12 cubed? So 12 cubed will be 1728 inch cubed. So therefore you say that 1 cubic foot is 1728 inch cubed. Is that okay? So we're going to transform these into cubic square units and cubic units. So that is basically 2-dimensional and 3-dimensional. And you can do same for all the others, right? Now, we are still going to go with the factor label method. All right. So here we have area and volume. Now, you may be familiar with this. So if you want to find the area of a rectangle, that is what the length times the width. So 8 inch times 5 inch is equal to what? 40 inch squared, because you're doing inch times inch, and that will give you an inch squared. Is that okay? So here, this is a 3-dimensional, right? So we had to do 8 inches times 5 inches by 6 inches. The length times the width times the height. All right, and now we did this inch times inch times inch will be what? Inch cubed. So therefore we have 240 inch cubed. Is that okay? Nice. Another one that you have to know is the area of a circle. An area of a circle is pi r squared, where r is the radius, right? So the radius is that from the center to any part of the circumference is what we call the radius. Not the distance from the center to any part of the circumference. So here, you do pi, and pi is on your calc, okay? So if you want to get a full value of pi, you will see the pi symbol on your calc. All right, so look for the pi symbol, okay, on the calc, and you can use that. But usually pi is giving us 3.142 many instances, right? So if you hit pi and you multiply, you get that. And here the volume of a cylinder, right? A cylinder is 3-dimensional, so you do pi r squared h. So you square the radius times the height, and that is what you have. Is that okay? So note these formulas, and these formulas are also provided on your formula sheet. Okay, that's the last table, and it says other useful information on your formula sheet on pages 2, 3, 5. Okay, so take note of that. Nice. Now, notice the units on the example above. Why are the units on the area squared? The units on the area are squared because anything multiplied by itself is said to be what? To be squared. Be careful. X squared means what? X times X. X squared is never equal to 2x. Okay? Anytime you multiply something by itself, that is what happens. Now describe the unit. Unit by unit by unit should give you a unit cubed. Is that okay? So cubic units denote 3-dimensional measurements. Now, if you want to find the volume of this figure right here, we have to use the formula pi r squared h. Okay? And that should give you 60.08 inch cubed. Is that okay? Nice. Right. Now here we are back to the factor label method, and we know how to do this from the previous section, which is section number 13. So if you have 8.5 inch multiplied by 8.5 inch, we're talking about this guy right there. It has an area of what? 93.5 inch squared, or square inches. Okay, so square inches, and that's it. So here, if we have 93.5 square inch and we want to transform or change that into centimeter cube, okay, using the factor label method, this is the process we have to go through. So write the initial as 93.5 inch squared, or square inch over 1, okay? And this is better written as 93.5 inch times another inch. Is that okay? Now notice that the inch is not squared, just the units. Is that okay? Now multiply the identity ratio, and we are doing this because on the identity ratio, to change from inch to inch squared, if you're looking at the third table, 1 inch okay, is 2.54 cm. Do you see that on the table? And that's the identity ratio. Now we are multiplying this twice because we are dealing with a square unit. So literally what we did is, if you want to find a square unit, we just square everything here. Is that right? Good. So cancel the units on top that match the units at the bottom. So because we are dealing with twice of that, we have that canceling twice of that. Okay, and then you have 2.54 times 2.54, and that is the cm cube. So your answer is just 603 centimeter cube, centimeter squared. Okay, right. Now, if you wanted to use the proportion approach, like I said, so 1 inch is 2.54 cm. Now we square it, and that should have given us 1 inch squared is equal to 2.54. So 2.54 squared. That should have given us 6.4516 cm squared. Now, what did we have to change? We had to change 93.5 inch squared. So we put 93.5 inch squared. And we don't know how many cm cube is there. We divide and divide. And that will give us the same answer. So our x literally is 93.5 times 6.4516. And we know that our answer should be in cm cube, cm squared. So 93.5. Okay. And that should give us 603 cm squared. So that's basically how we are dealing with this at this point. Okay. So I just wanted to give you the alternative way if you want to go by the proportion approach. Okay. Now we have this here, and we have a three-dimensional. So we have this right there. Suppose you buy a rectangular tote that is 25 inch by 16, okay, by 12. That should give you 4,608 inch cubic inch. All right. Now, if you have to change that into a cubic feet, is that okay? Now, if you look at the formula sheet, we know that 1 feet is 12 inches. Is that right? So because we are dealing with a cubic unit, you multiply that 3 times, going by the factor label method, and that should give you 2.7 cubic feet. Gucci? Nice. So here, you see an ad for an apartment to rent in Madrid that will sleep 5 adults. It is 90 square meters. How big is this in square feet? Okay, so because there's no direct relationship between meters and feet, you have to go by the third table. If you're looking at the third table, you have 1 yard being equal to 0.9144. Is that okay? So this is what you have to change. So you do that, and then you multiply, you're going by the factor label method. 1 yard is that. Now, because you are dealing with the square unit, you have to multiply that twice. So that's why we have this and that. And then finally, you will do 1 yard is 3 feet. And you have to do that twice because you are dealing with the square unit, and that gives you the final answer. It's that. Is that okay? Nice. Now, you're putting a new carpet in the family room. The room measures 16 feet by 24 feet. The carpet comes in square yards, not square feet. How many square yards of carpet do you need to purchase. So you change 16 feet into yards and you change 24 feet into yards, you multiply and you get a square yard. Alternatively, you can do the multiplication, 16 feet by 24 feet, you get, the answer will be a square unit, right? Square feet. And then you change from square feet into a square yard. So that gives you that. And then you transform that into a square yard. So that's the alternative, right? You could have changed the unit before doing the multiplication. Nice. Now, the bed of a track is 12 feet by 5 feet by 3 feet deep. What is the volume? So the length times the width times what? The height. So this by that, and that gives you that. Now you want to change from cubic feet into cubic inches, all right? And you know that there's a direct relationship between inches and feet, right? So you do that 3 times using the factor label method and your answer comes up. Is that okay? Nice. Now, how about how would you convert cubic yards to cubic inches? And this is the way you go about this conversion. Is that okay? Nice. So if you really master the factor label method, this should be an easy approach, okay? Nice. Now let's look at non-rectangular volumes, cylinders, which we already know the formulas to those, right? So pi r squared h. All right. Now, one thing you have to watch out for here is that a soup can measure 8.8 centimeters in diameter, right? Now, if I have that, this is my diameter. Okay, from one end of the circle to the other end of the circle, passing through the center. So this is the diameter, right? Now, the radius is half of the diameter, right? So if you are given that, you have to divide that by 2 because the formula says we should use pi r squared h. We divide that by 2 and that gives us 4.4. And we multiply by the height, 7.2. And we have the final result as that. Okay, nice. Now, a vintage coffee tin is 7 inches tall and has a radius of 3.5 inches. How many cubic centimeters is that? Is that okay? So you find that in inches and then you change from a cubic inch into a centimeter cube. And because you are doing 3 of that, you're dealing with a cubic unit, you multiply 3 times, okay? And that is how you do that. Okay, now we talk about liquid volumes. In liquid volumes, you have 1 cubic centimeter is 1 milliliter, right? And you have that on the last but one table on pages 2, 3, 5, the yellow sheet you have right in front of you, okay? And that is under special conversions, okay? Special conversions, you will find that, okay? You'll find these formulas under special conversions. And we'll do a few of those problems. So a rectangular aquarium measures that, and you want to find the volume, okay, in liters. So first you find the volume in centimeter cube, and then you change that into liters, and that gives you 81 liters because 1 liter is 1,000 centimeter cube. Okay, so that gives you 81 liters. Number 2. So Jane arrives home to find that her 40-foot by 32-foot basement has 18 inches of water in it. How many gallons of that? Now, be very mindful all the time whenever you want to do these multiplications. Make sure you harmonize your units. So make sure you realize that this is in inches. Okay, so watch out for that. So you have to change from inches into feet, or you have to decide to change foot and foot into inches, then you can multiply. So make sure the units are harmonized. So now we changed 18 inches into feet, and that gave us 1.5 feet. Is that okay? Right, because one foot is 12 inches. And we did the volume. Now we have to change this into gallons. But looking at the special conversions table, 1 cubic feet is approximately 7.4805 gallons. So what do? We multiply that by 7.4805 gallons, and that gives us the volume of water in Jane's basement. Sounds good? All right, thank you. Now, we do this as well, and here we want to find the volume, how many gallons of water can it hold, right? A bathtub of that. So now we change that into gallons, and we have to use the special conversions. 1 cubic feet is 7.4805 gallons, and that gives 180 gallons. Sounds good? Nice. And again, we're talking about the same, we're talking about a pool, right? Has 6 feet radius, and it's filled to a depth of what? 5 feet. So now we use pi r squared what h to find the volume. Okay, so this is the height. So pi r squared gave us that answer, and then we multiply by the height, and that gave us the volume of water in the pool. Is that okay? Nice. Now, if we have to change that into pounds, that is the amount of water we have. And again, using the special conversions table, a gallon of water is 8.33 pounds, okay, on the special conversions table. So basically, that is all we have to know, all we have to do under 2-dimensional and 3-dimensional. So basically, 2-dimensional, we're talking about a square unit, and 3-dimensional, we're talking about cubic units. Is that okay? So you're going to utilize pages 2, 3, 5 a lot to get these done. All right. So basically, that is all we have to know under 2-dimensional and 3-dimensional. So I want to see you soon for us to talk about dosage calculations. All right. So thanks for your time, and I will see you soon.